Now, there is another function that is called one-to-one correspondence. One-to-one correspondence is basically a function that is both that has the property of one-to-one and onto. So basically, any function that is both one-to-one and onto will be called one-to-one correspondent, or sometimes they call it bijection. Okay. Next is inward function. Okay. Inward function is a function that map the element in the codomain back to the domain. Okay. For example, let's say that you have a function f here from set A to set B. Let's say that in set A, you have a member called A small letter a, and in set B, you have a small letter b. And the function f is mapping an a to b. Let's say here. So then inward function, which we will usually denote it as f inward, f to the power minus 1, will be a function that is mapping the b in the set of capital B back to the A in the set of capital A. So it's opposite to the function f. Okay, this is an inward function. Now the important point is that not every function will be and will have an inward function. Okay, only the bijection function will have an inward function. Okay, which means that a function that will have a inward has to be one-to-one and onto. Okay, so if you get asked what is the inward function of this function, first you have to check if this function is onto and one-to-one. Okay, because if that function is not onto and one-to-one, it doesn't have an inward function, so it doesn't make sense to find an inward function because it doesn't. Okay, the reason why it need to be a one-to-one and onto, because let's just say that you have a function f, okay, function f that map from, let's say, a set b f. Yeah, let's say a has a b c, and then b has 1 and 2. Okay, so for inward function you would have for one-to-one and onto, you would probably have something like this: 1 1, and I have to have another example, sorry, 1. So as you can see, this is a f is bijection, okay, which is one-to-one and onto. Okay, so the inward of f would be something like this, right? We can say a, okay, b, but inward will be inward, okay, a b c 1 2 3, and it will be like this, the opposite. Okay, now what happens if you have a function that doesn't map, that is not one-to-one onto? Let's say you have a, and you have b, a b c 1 2 3. Let's say this is not one-to-one. Say a to a 1, b to 1, and then c to 3. Okay, so the inward function of this one would be a b c 1 2 3. So this one pointing back, this one pointing back, this one pointing back. You see the problem here? Now you have element 1 is mapping to two members or two elements, right? A and B, right? So make f inward is not a function, right? Which means that this function doesn't have an inverse. Okay, so it's not one-to-one and not two. This is not one-to-one and not two. Okay, so it's not, it doesn't have. Okay, let's see some example. Let's say that f is a function from the real number set r to the real number set r. F of x is equal to x squared. Okay, what is the inverse function of this one? First, you have to make sure it's one-to-one and onto. Okay, which I can immediately tell that f of x equal to x squared is not a one-to-one. Why? Because I can say x1 is equal to 1, x2 equal to minus 1, but then f of x is equal to 1 squared or minus 1 squared. Okay, this is not one-to-one, so it will not be any lower than 0. So some of the domain here will not be able to find a value of x. Okay, so this is not, doesn't have an inverse. Now let's say function g from integer set to integer set, say g of x equal to x plus 1. Okay, it say that what is the inverse function of g. Okay, so g of x is equal to x plus 1 from the real number, from the integer set to integer set, right? So this one is definitely one-to-one, because okay, let's just add. So f of x equal to x squared, where f is equal to z to z. Okay, you can see that this one is not one-to-one, because let's say that f of x1 equal to f of x2, so x1 squared is equal to x2 squared. However, x1 will be equal to plus and minus x squared. As you can see that more than one f of x equal to f of x1 is equal to f of x2, but then x1 is not equal to x2, so this is not. Oh, now we do the g. So g of x equal to x plus 1, but g is a function from z to z. Okay, now let's say g of x1 equal to g of x2, so it's x1 plus 1 equal to x2 plus 1. You can say x1 equal to x2, which means that g of x is 1 to 1. Now, is it onto? Well, we can check. Is it onto? You say g of x equal to 4x plus 1. Oh, not 4x plus 1, sorry. X plus 1, sorry, x plus 1. Okay, so let's say g of x1 equal to g of x2, x1 plus 1 equal to x2 plus 1, x1 equal to x2. Again, the function is 1, 2, 1. Okay, now on to g of x equal to x plus 1, g of x is a function from is z to z, right? So let's say if we can find a y such that we can't find x, let's say y is equal to 5, then x is equal to 4, y equal to minus 1, x will be equal to minus 2. I just trying to substitute the value of y and find value of x corresponding to the value of y. You will notice that every single y that you put in, you can always find the value of x. Okay, so the function is onto. So we have both onto and one-to-one. So g of x has a so g of x has, so inward can be found like this. You substitute g of x equal to x plus 1. So it's y equal to x plus 1. So you just substitute x by y, y by x. So x equal to y plus 1. So y will be equal to x minus 1, which means that f inverse of x will be equal to x minus y. That's it. Okay. And then the answer here. And then the last one is h is a function from a to b. Okay, h is a function from a to b. Then h inverse is the function from b to a. If you look here, h is 1 to 1 and 1 to 2. So we have no problem finding the inverse. Okay.